This is Numbers with Nicole, and we're going to do our lesson on a volume of a sphere. So what is a sphere? A sphere is a 3D figure shaped like a ball, where every point on the surface is the same distance, which we call the radius, from the center. So we look at this purple sphere over here. We have this red line that's drawn. That's the radius. So that's just one of many radii that we could draw in this circle. So if I go from the center to any point on the sphere, those distances, those red lines that I'm drawing, are all radii. They are all equal distances. Okay. And then this other part of the sphere here is called the greatest circumference. So if you see this dashed line, that is the circumference, which we know is the distance around a circle. A circle is two-dimensional and a sphere is three-dimensional. So this blue dashed circle is the widest circle that we could draw around the sphere. Right? Think of it like the equator of the Earth or the prime meridian. So another greatest circumference that we could draw is this vertical one that goes around the sphere here. So again, it's the widest circle that we could draw around a sphere. That's what we mean by the greatest circumference. If I were to draw a circle around the sphere up here, right, that's not the biggest circle I could draw. That's a tiny circle. So when referring to a sphere, the two parts we have are the radius, and another part that we could talk about is the greatest circumference. So if we think about someone gave you a random sized ball that for sports or something that you were going to play with, and you wanted to know what the radius of the ball was, or so that you would know if it would fit in the basket. Could you just take the ball and see if it would fit in the basket? Yes, but we're thinking mathematically here. So we wouldn't cut the ball in half and then measure the distance from the center to the edge to get the radius. We wouldn't do that. So what we would do is we would measure the circumference and then use the circumference of the ball or of the sphere and then use that to solve for the diameter or the radius. We will do that later. We're not going to worry about that now. So volume of sphere, there's two formulas, but they're equivalent. They're the same thing. It's just how you want to enter it into your calculator. So in this formula, V represents the volume, R represents the radius, and since we're talking about volume, it will be in cubed units or units cubed. So if we were talking about feet, it would be feet cubed. If we're talking about meters, meters cubed, miles cubed, whatever it is, should be cubed units for volume. So we could do 4 over 3 times pi r cubed, or r raised to the third power. Or you could do 4 times pi times r to the third and then divide that answer by 3. It's all multiplication there and then division. So it doesn't matter how you enter this into your calculator. The important thing with this formula is that we have r being raised to the third power. And so that means that we're going to have r times r times r. So if our value was 2, it would be 2 times 2 times 2, which is 8, right? R raised to the third is not the same as 3 times r. So again, if our radius, let's say, was 2, r cubed would be 8. It would not be 6, right? 2 times 2 times 2 is 8, or 2 raised to the third is 8, not 3 times 2, which is 6. Okay, so make sure that you are using the raised button in your calculator, which would be the caret. Looks like this. Right, and then also another thing to keep in mind is that since a sphere has a circle in it, it's parts of a circle, right, we could be given a diameter, which is 2 times the radius. And so to use this formula, which has radius in it, if we're given a diameter, we should divide it by 2. This is previous knowledge from previous lessons that we've gone over here. So let's do some examples. So here we're going to find the rounded volume of a sphere. So I'm going to write my formula down. 4/3 times pi r cubed. So here I see I have a segment that goes from one end of the circle to the other through the center. That means this is a diameter. And in order to use my volume formula, I need a radius. So I'm going to divide that diameter by 2, and I get 21. So I'm going to go over to my volume formula. I'm going to replace the r with 21. Okay, and that's going to be raised to the third power. So I'm going to put this in my calculator. You could type it in just as you see it. I'm going to do the pi times the r cubed first. Pi times 21 raised. I push the little caret button in my calculator to the third. And I'm going to multiply that by 4 divided by 3, which is the same as 4/3. So our volume here is 38,792.38 But since it wants it rounded to the nearest tenth, our approximate value, 38,792.4 centimeters cubed. So just like with area and circumference of a circle, we can find the exact volume of a sphere. So what do we mean by exact? Exact means we are not going to push the pi button, which means pi is a number that continues on. It is irrational. So anytime we push the pi button in our calculation, that gives us a number that we would end up rounding. Rounding is not an exact answer. So when we see the words exact, that means that pi is just going to be part of our solution. It is not going to be something I actually push in my calculator. Use the other format of the formula for this one. Here we have a segment that's from the center to the edge, so our radius is 6 feet here. So volume is 4 pi times 6 raised to the third over 3. Now, because we want the exact, I'm going to take my pi and I'm just going to put it at the end, and I'm going to actually do the calculation involving the 4, the 6 cubed, and the 3. So 4 times 6 raised to the third power. Divide that answer by 3. Now notice in my calculator I didn't push pi at all because pi is irrational. I want an exact answer. If I push pi, I'm going to be rounding, and that is not exact. So we end up with a volume of 288 pi feet cubed. Again, our units are cubed units. So again, exact means don't push the pi in your calculation, but it's going to be part of your answer at the end. All right, so the last example I wanted to do with you is involving a hemisphere. So if we think about this, a hemisphere is half a sphere. All right, so all we're going to do for this question is we're going to multiply 1/2 times the volume of a full sphere. And here we're going to round. We could find exact also, but that's not what we're doing on this one. So 1/2 times the sphere formula, which is 4/3 pi r raised to the third power. And here we are given a radius. So 1/2 times 4/3 pi times 5 to the third. So you're thinking, well, why did you put all these parentheses in here? You don't need all of them. This is just multiplication between all of the terms. So we can now put this in our calculator. 0.5 times 4/3, here's one way to put that in, times pi times 5 to the third power. And we're going to round, so we have a volume that is approximately 261.7 ... And it says to the nearest whole cubic inch. So our final answer here will be 262 inches cubed.